In this video, we will begin looking at how we can solve an inequality for a variable. As we do, we will find that solving inequalities is just like solving equations, where we balance each side of the equation, or inequality, to get the variable alone. The only exception to this is if we multiply or divide by a negative. When you do, you must flip the inequality symbol. Let's take a look at an example where we solve an inequality like an equation and may have to flip the symbol if we multiply or divide by a negative. Before we would balance through the equal sign, now we balance through the inequality sign. To get x alone, we start with the addition and subtraction by subtracting 7 from both sides of the equation. This gives negative 5x is less than or equal to 10. Get the x alone by dividing both sides by the negative 5. Notice here we are dividing by a negative. This means the inequality is going to have to switch directions. We now have x is greater than or equal to negative 2. To help us visualize this solution, we can graph it on a number line. At the number negative 2, because the inequality has the or equals to, we are going to need a closed dot. The inequality also opens to the x, showing that x is greater than the negative 2, meaning we need to shade the values that are larger than the negative 2. We now have a picture of the solutions to this inequality. We can also represent this inequality using interval notation. Interval notation is small, comma, large. The small number's negative 2, comma, the largest number on the graph goes off forever, is infinity. Because there's a closed circle, or an or equals to at negative 2, we are going to need a square bracket on the negative 2. As always, infinity is always a curved bracket. We now know that anything between negative 2 and infinity, when plugged in for the x, makes the inequality a true statement. Let's try another equation and see how it solves. This equation, being slightly more involved, will need us to simplify first by distributing the 3 through the parentheses. This will give us 3x plus 24 plus 2 is greater than 5x minus 20. After distributing, we can combine like terms on the left side, giving us 3x plus 26 is greater than 5x minus 20. Next, we notice that the variable is on both sides, so we will subtract 3x, moving the small one so all the variables are on the same side of the inequality. 26 is greater than 2x minus 20. By adding 20, we can begin isolating the variable on the right side. 46 is greater than 2x. Finally, dividing by 2 will tell us that x is less than the 23, or 23 is greater than the x. We can graph this again on a number line, so we have a visual representation of our solutions. We will use an open dot at 23 because it's not equal to. Notice the inequality points at the x. The x is the smaller value here, so we shade our line down towards smaller numbers. We can represent this in interval notation, going from infinity to 23. Infinity always gets a curved bracket, and 23 also will get a curved bracket as a result of not being equal to.